In this video, we are going to talk about how we apply convolution theorem on Z transform. Let us begin with the statement. The statement of convolution theorem, it goes like this. To apply convolution theorem, we need two sequences. So let me take Fn and Gn are the two sequences. To denote the convolution, we are using this symbol star. So we have Z transform of Fn star Gn is equal to f of z times g of z, where f of z equal to z of f of n and g of z equal to z of g of n. To define the convolution of two sequences, that is f of n star g of n, we have sigma r equal to 0 to infinity f of r times g of n minus r. That means in the first function fn, we change n equal to r. In the second function n, we have to change into n minus r. And instead of this star, we are going to multiply these two values. Okay. So we know that in a geometric progression, if the terms are like this, 1 plus r power 2 up to etc., then we have this rule, r to the power n plus 1 minus 1 divided by r minus 1, with the condition if the r value is greater than 1. If the r value is less than 1, then I can use this series as 1 minus r to the power n plus 1 divided by 1 minus r. In a geometric series, the first term we denoted as a, the common ratio we denoted as r. Okay, let's discuss some of the problems based on this. Question number 1, we have to find z inverse of z power 2 divided by z minus a times z minus b using convolution theorem. So let us split this into two parts. So this z power 2, I can write z times z. In the denominator, I have two linear factors z minus a and z minus b. So we will write the first term as z by z minus a times z by z minus b. Then this star I can replace by star. Then this will be my first sequence. So z inverse of z by z minus a, that is going to be a to the power n, star z inverse of z by z minus b, it's going to be b to the power n. Now apply the rule of convolution. We have f of n star g of n, that is going to be sigma r equal to 0 to n f of r times g of n minus r. So I have sigma r equal to 0 to n. In the first sequence, I have to replace n by r, so this will become a power r. In the second term, this n I have to change into n minus r. So this will become sigma n equal to 0 to n a to the power r. This b power n minus r, I can write b to the power n times b to the power minus r. Since the in the summation, which one is varying? We have to take n r equal to 0 to n. So the value of r is going to change. So whatever you have in terms of r, keep inside the summation. Without r, you can take outside. So let me take this bn outside. So we have b to the power n sigma r equal to 0 to n a power r times b power minus r. So this is going to be sigma r equal to 0 to n a power r. This negative exponent I can bring down. So this will be b to the power r. Or I can say b to the power n summation r equal to 0 to n. I can write this as a by b the whole power r. So now we have to simplify this one. So let me do the next step. So here we have r value begin from 0 to n. So I have to substitute r equal to 0, then r equal to 1, then r equal to 2 and so on. So we will get this one. So this is like in the format of a plus AR square and so on. So as I told you before, if R value is less than 1, then I can use this formula, A by A times 1 minus R to the power n plus 1 divided by 1 minus R. Remember, we have a B power n outside. Okay, so in place of R denotes the common ratio. In this question, this is the common ratio. A over B is the common ratio. So we have R equal to A over B. So this would become 1 minus A over B, the whole power n plus 1 divided by 1 minus A over B. So by simplifying this, I will get B to the power n plus 1 minus A to the power n plus 1 divided by B power n plus 1. This divided by B minus A divided by B. Okay. So the next step, this will change into reciprocal. The division will become multiplication. So we have this term multiplied by B by B minus A by B, that is going to be B by B minus A. So we have B to the power n, B power n plus 1 minus A power n plus 1 divided by B power n plus 1 times B minus A divided by B. So this is nothing but B power n plus 1 minus A power n plus 1. In the denominator B power n plus 1, I can write B power n times B multiplied by B by B minus A. Okay, this one B by B minus A. Because we have 1 minus A over B in the denominator, this one. So by taking LCM, this will be B minus A by B. And if I take the reciprocal, this would become B by B minus A. Okay. Then I can cancel B power n. I can cancel B and B. So we have concluded that the final answer is B to the power n plus 1 minus A to the power n plus 1 divided by B minus A. Let us discuss one more thing. Z square. Find Z inverse of Z power 2 divided by Z minus 1, Z minus 3 using convolution theorem. So like previous question, since this is Z power 2, I can write Z times Z. Then we have this one, Z inverse of Z by Z minus 1 star Z inverse of Z by Z minus 3. So this one will be 1 to the power n and this one will be 3 to the power n. Then let me write the definition of convolution of two functions. That is going to be f1 star gn. It is equal to sigma r equal to 0 to n f of r g of n minus r. So we have sigma r equal to 0 to n. First one, this n we replaced by r dot. In the second one, this n replaced by n minus r. So this is nothing but sigma r equal to 0 to n. 1 power r is nothing but 1. We have only 1 power r. This one can be written as 3 power n times 3 power minus r. Then I will take 3 power n outside. Remaining term sigma r equal to 0 to n. This 1 power r, 3 power minus r, I can write 1 over 3 the whole power r. Then by replacing r by 0, we will get 1. By replacing r by 1, I will get 1 over 3. By replacing r by 2, I will get 1 over 3 plus 2 and so on. In this question, the value of r equal to 1 over 3 because this is r value, the common ratio, which is 1 over 3. 1 over 3 is the less than 1. Okay, this number 1 by 3 is less than 1. So we have to use this formula. So by using this formula, we will get this one. By taking LCM, we will get this one. Then the final answer will be 3 power n plus 1 minus 1 divided by 2. Remember, this is going to be 1 because 1 power n plus 1 is nothing but 1. This is going to be 2. So 2 by 3. Okay, so we have like this 3 power n, 3 power n plus 1 minus 1 divided by 3 power n times 3. This fraction 3 minus 1 by 3 is nothing but 2 by 3. If I take reciprocal, it will be 3 by 2. So final answer, cancelling 3 power n, 3 power n, cancelling 3 and 3, we have remaining with this term. So this is my final answer. Question number 3. Find z transform of z inverse of z power 2 divided by z minus a the whole power 2. Okay. So as usual, we have to split this into two functions. So z power 2, I can write z times z. In the denominator also we have z minus a the whole square. So I can write like this, z inverse of z by z minus a times z by z minus a. Now by splitting this into 2, I have this one. Since we are going to apply convolution, I have to use this star symbol. So this will be a to the power n, this also a to the power n. Then we will write the definition of convolution. So what is the definition of convolution? In the first one, we have to change n equal to r. In the second function, we have to change n equal to n minus r. So we will get sigma r equal to 0 to n, a to the power r, a to the power n minus r. By taking a to the power n outside, we have summation r equal to 0 to n, a power r multiplied by a power minus r. Okay. Now by comparing these two, we will come to know the bases are equal. So I can add the powers. So this is going to be a to the power r minus r. Of course, we have a power n outside. So this will be a to the power n sigma r equal to 0 to n, a power r minus r. R minus r is 0. But anything power 0 is going to be 1. But here the sigma, the value starts from 0 until n. So if I replace the value by 1, 2 and so on. So in this one, if I replace r by 0, I will get 1. If I replace r by 1, I will get 1. If I replace r by 2, I will get 1 and so on. Since we are beginning the summation from 0 to n, there will be n plus 1 number of terms available. So the final answer is a to the power n. This summation is nothing but n plus 1. So the final answer is a to the power n times n plus 1. Try these two problems by yourself. See you in the next video.